Hello and welcome to MSA Prep. My name is Lisa Green and today I'm going to go over some problems regarding geometry and measurement to help you all prepare for the Maryland State Assessment, which we call our MSA. Our first problem for today deals with scale drawings. If you look at my drawing, we have Gaithersburg and we have Baltimore. What is the distance in miles between Gaithersburg and Baltimore? Now, the scale that's given is 1/4 inch equals 7 miles. So in order to determine the distance between Gaithersburg and Baltimore, first I need to measure using my ruler as my tool, my measuring tool, to determine in inches what's the length between Gaithersburg and Baltimore. So when I use my ruler to measure, I see the length of this line segment is actually 2 inches. So if we want to solve the problem, the first thing we need to do is to set up a proportion. Proportion will start with our scale. Again, the scale says for every 1/4 inch, it's actually equal to 7 miles in actuality. So I'm going to put 1/4 inch over 7 miles. That's my first ratio. Now we know two ratios form a proportion. So I need to make my second ratio. So I'm going to put my equal sign. And if I look at my units, you need the same units on top as the same units on the bottom. So if I have inches on the top, I have to continue with inches on the top in my next ratio. If I have miles on the bottom, I'm going to continue with miles on the bottom. So again, remember we measure with our ruler and we determine the distance on this paper between Gaithersburg and Baltimore is 2 inches. So in actuality on the map, it may be inches, centimeters, etc. But we want to find out what's the distance in real life. Okay, so I know 2 inches will go on the top because I'm keeping my same units on the top and same units on the bottom. But in actuality, I don't know how many inches will equal to the amount of miles. So I have an unknown. Since I have an unknown, I will use a variable. So now we have our proportion. We have two ratios. We have inches on the top and we have miles on the bottom. So now in order to solve it, what we do to solve for the x, we're going to cross multiply. Okay, so I'm going to cross multiply. I'm going to multiply x times 1/4 inch, and I will get 1/4 times x equals, next I'll multiply 7 times 2. Okay, so now after we multiply, we're going to simplify it. So I'm going to go to my next sheet because I'm running out of space. We have 1/4 times x equals 7 times 2. So instead of using 1/4, I know 1/4 as a decimal is equal to 0.25 or 25 hundredths. Now to get that, if you're not sure, you also may use the graphing calculator or any calculator and divide 1 divided by 4 and you will get 25 hundredths. So 1/4 equals 25 hundredths. So instead of writing 1/4, I'm going to use 25 hundredths. So we have 25 hundredths times x is just 25 hundredths x equals 7 times 2, which is 14. So now we have a one-step equation. In order to solve for x, I'm going to do the inverse or the opposite operation. The opposite of multiplication is division. So in order to get the variable, which is x, all by itself on one side of the equation, we're going to divide each side of the equation by 25 hundredths. Now, if I look on the left-hand side of the equation, 25 hundredths divided by 25 hundredths cancel. So my two coefficients cancel. My coefficient cancels. Now I'm left with x equals 14 divided by 25 hundredths. Now I'm just going to use my calculator, and I'm going to put in 14 divided by 25 hundredths, and we get x is equal to 56. And the units were miles. So in actuality, the 2 inches that we saw earlier, which represents the line segment on the paper, in actuality, the distance from Gaithersburg to Baltimore will actually be 56 miles after we made our conversion. Now, how do we know our answer is correct? We can check our answer to determine our answer is correct by just plugging in the unknown, which we said was 56 miles, plug it back into our original proportion. Okay, now we're going to actually plug in the answer we got of 56 into our original proportion to make sure that what we saw was actually the correct answer. Now, how do we determine if our answer was correct? When we plug it back in and when we cross multiply, the answer should come out the same. So let's try it. So let's cross multiply 1/4 inch times 56. And again, 1/4 was equal to 25 hundredths. So we're going to say 25 hundredths times 56 should be equal to 7 times 2. So when we multiply 25 hundredths times 56, we get 14. Bring down the equal sign, and 7 times 2, of course, is 14. So does 14 equal 14? Yes, it does. So that means we solved it correctly. So we're going to go on to our next problem. And our next problem actually deals with composite figures. I know some of you out there may have a little trouble with composite figures, but it's really not that simple because I'm going to show you an easy way to actually solve. So if we look at our diagram, it says Sydney is refinishing her kitchen floor. The dimensions are shown below. This is Sydney's kitchen floor. She has a large kitchen. She has, if we look at the shape, it's not one shape, it's composed of a series of shapes. Now we must remember the figure is not drawn to scale. So this is just a drawing. So the units that you see listed, they're not the actual lengths. Okay, now again, if we look at our composite figure, we see that there are a variety of shapes in our composite figure. I see a rectangle, we have a square, we have a triangle on top, and we have a half circle on the right hand side. So how do we do this? The question is, what is the area in square feet of Sydney's kitchen floor? Round your answer to the nearest whole number. Use 3 14/100 for pi. Okay, so now let's start. So if they tell us pi, again, that means we're going to have to do something with this circle over here. So what we need to do first is break this up into various shapes. Now again, let's start with the triangle on the top. Okay, the triangle on the top consists of 6 feet, 8 feet, and 10 feet. Now first, because it's asking us to find the area, we need to remember the formula for finding the area of a triangle. To find the area of a triangle, the formula is area of a triangle. The formula is A equals A for area, 1/2 of your base times height. Area equals 1/2 base times height. So if we go back to our triangle in the figure, the base is 6 and the height is actually 8. So if you can look at the dimensions, so I'm going to substitute in, instead of writing B for base, I'm going to write 6 and I'm going to write an 8 for my height. Now notice how there's no symbols in between the variables. When there are no symbols in between the variables, that means to multiply. So I'm going to put a little dot that indicates multiplication in between everything. So now we have 1/2 times 6 times 8. Now instead of using my fraction 1/2, I can also turn into a decimal. 1/2 is really 50.5. So 1/2 is 0.5, or I can say 1/2 of 6 is 3. And then 3 times 8. 3 times 8 is equal to 24. So the area of the triangle is 24 square units. So that's our first shape. Okay, the next shape we have, let's look down the bottom here in our diagram. The next shape will actually consist of the square. If we draw an imaginary line, we can see that's a square at the bottom. So now we have to find the area of the square. Okay, let's write area of square. The area of a square, the formula is area equals side square, or S squared. So if I go back to my diagram, the length of each side of the square is actually 6 feet. So therefore, I'm going to substitute in 6 for my side. So the value of each side is 6. So 6 squared, to solve it, this is an exponent. 6 to the second power means 6 times 6. 6 times 6 is equal to 36. And it's going to be square units because it's area. So therefore, the area of the square in this diagram, in my composite figure, is actually 36. So now we have found the area of the triangle, and we have found the area of the square. If we go back to our diagram again, let's look at the area of the circle. We have a circle on the right-hand side. It's not a full circle, it's a half circle, but we're still going to use the area formula for a circle. So now let's put area of a circle. Okay, the area formula of a circle is pi times radius squared. I hear you all out there saying that because I know you know it. So area equals pi. The measurement for pi is approximately 3.14 or 3 1400 times. Now if we go back to our diagram, if we look, the distance from here to here actually represents our diameter. So in order to find the radius, because the area of the circle, we need to find the actual radius. So to find the radius, we're going to divide our diameter by 2. So if our diameter is actually 8, 8 divided by 2 will give us 4. So 3 1400 will be times 4 to the second power, or 4 squared. So now we can just simplify. Order of operations tells me I need to do or solve my exponents before solving multiplication. So I'm going to solve my exponents. 4 squared actually means 4 times 4. 4 times 4 is 16. So I'm going to bring down my multiplication symbol and my 3 1400. So area is equal to 3 1400, which is pi, times radius squared, which is 16. So let's multiply it out, and we have 3 1400 times 16, and we get 50 2400. And that's also square units because it is area. Okay? So now we have our area of the square, of the circle. Now, last but not least, if we go back to our figure, I know we have so many shapes in here, but when you're actually doing your test and you see a problem similar to this, don't get frustrated, don't be afraid, just look at it. You know the area formulas of the different shapes. All you're doing is breaking it apart, and then in the end we're going to put it back together. Okay, so our last shape we're dealing with is the actual rectangle. Okay, and a rectangle consists of majority of Sydney's kitchen. So this is our rectangle. Now, we need to find the area of this rectangle. So basically, to find the area of a rectangle, we're going to multiply length times width. Okay, so if we look at our length, then we can determine what's the length of that side. Okay, so therefore, easiest way to do this is to look on top. We have 6 feet that comprise this section. We have 8 feet that comprise this segment, and 6 feet for this. So if we add them together, we have 6 plus 8 plus 6. 6 plus 6 is 12. 12 plus 8 is 20. Okay, so the area again, area of rectangle is equal to length times width. Okay, so we can just substitute in 20 times, and the length of each side, the width of each side is 18. On this side it's 18, but on this side we have actually 18 consists of the entire side. So if we go back, 18 consists of the length of this entire side. Now remember, when we found the area of a square, this little side of the square was actually 6 feet. So we're going to have to subtract that out. Or we can just look at the opposite side, and we know that 2 plus 8 plus 2 will actually give us 12. Okay, or if we subtract 18 minus 6, we still get 12 for the length of this side. So the length of the other side will be 12. So if we go back to our formula, we can substitute in length times width, and we get area equals 20 times 12. We multiply it out. We know 2 times 12 is 24. We add a 0 to it, it should give us 240. Okay, so let's just double check it using our calculator, and we do get 240. So we get 240 square units. So again, now if we go back to our diagram, we found the area of the triangle on the top, we found the area of the circle over here, we found the area of the square down the bottom, and we found the area of the entire rectangle. Okay, now one more trick. Again, the figure is not drawn to scale, and if you look in the figure, again, it's not a whole circle, it's a half circle. So when we go back to our area formula for a circle, we're going to have to divide that by 2, because this is the area formula for the entire circle. But again, it's not a full circle, it's a half circle. So if we divide 50 and 2400s divided by 2, we actually get 25 and 1200s for the half of a circle. So that's our half circle, okay? So now we've got all the areas for each shape that comprise our composite figure. If we go back and add them all up, this will give us the total area for Sydney's kitchen. So let's see what Sydney's kitchen, her actual area will be. So we're going to use our graphing calculator. We're going to add 24 plus 36 plus, remember, the 25 and 1200s, that represents half of the whole circle, because in Sydney's kitchen, she had half a circle, not the full circle, plus 25 and 1200s, plus 240 square units for the entire rectangle. So if we look at our answer, the total of all this added together, we get total area, go back to our problem, total area equals 325 square units. Now remember, it asks us to round our answer to the nearest whole number. Although the exact answer was 325 and 1/10, rounded to the nearest whole number would be 325 square units for the total area of Sydney's kitchen. Okay, so I know that was a lot, but again, it's not too complicated. Just take your time, divide your composite figure into different shapes, and I'm sure you will be able to solve the problem. Okay, we're going to move on to our next problem. Okay, our next problem again involves a figure, but it's a different kind of figure. It's not so complicated as our composite figure. This is actually, if we look at it, it looks familiar. It looks like a baseball diamond. And it is a baseball diamond. The baseball diamond consists of the 4 sides. Okay, let's go to our question. It says the distance between the bases on a baseball diamond is 90 feet. What is the distance D in feet between the home plate and second base. Round your answer to the nearest whole number. So let's go back to our diagram. Okay, they asked for the distance between second base and home plate. So the distance between the two bases are actually what we're looking for, which is D. So if we look at it, we have all these little squares. Okay, these squares represent the right angle. The right angle means that it's a right triangle. So therefore, if I look at one, the right angle, I have two right angles actually that make up my diamond or my rhombus. So I have 90 feet for the length of one side and 90 feet for the length of the other side. So actually, it looks like it's in isosceles triangle so far because I have two sides equal for if I'm just referring to my triangles. Okay, so we have one triangle on the left, then we have another triangle with our same dimensions on the right. So let's just pick one of the triangles. Doesn't matter which one we choose. But if I know it's a right triangle, what formula do we always associate with a right triangle? Did I hear it? You guessed it, the Pythagorean Theorem. Pythagorean Theorem says the sum of the square of each side is equal to the square of the hypotenuse. So let's write our formula. The formula for the Pythagorean Theorem consists of a squared plus b squared equals c squared, where a and b are your bases and c is called our hypotenuse. Now, how do we know which is which? If we go back to our diagram, the two bases are always your shortest side. So these are the shortest side. And your hypotenuse, a trick to remember the hypotenuse, which represents C, is always diagonally right across from the right angle in your triangle. Okay, so this is our right angle in the triangle. So directly across it is our D. So if I draw my triangle over, if I take it out and draw it again, we can name this 90 feet, 90 feet, and we don't know what this is, so that's our D. So again, the right angle is directly across from our hypotenuse. Okay, so this would be A, this would be B, and this is actually C. Okay, so I'm just going to substitute in what I know. I know that A is 90 feet, so I'm going to say 90 squared plus 90 squared is equal to, do I know what C is yet? No, I don't. So I'm going to say C squared. Now, order of operations tells me I must simplify my equation. Order of operations says do exponents before we do addition. So 90 to the second power, if we take off our 0, we know that 9 times 9 is 81. Okay, but we're doing 90 times 90, so we have 2 extra zeros. So I can just add my zeros in the end. That's 8100. Okay, plus again, 90 times 90 is equal to 8100 equals C squared. Okay, so now I need to simplify the left-hand side of my equation. I have 8,100 plus 8,100. If we go over here, we add them up, we get 16,200 is equal to C squared. Now, I still have my exponent. So how do I get rid of the exponent? Okay, simple. Just take what we call the square root. You're going to take the square root of your answer. So our answer when we simplified the exponent was 16,200. So the square root of 16,200 is equal to C. So I'm going to use my graphing calculator to find the square root of 16,200, and we get 127. I'm going to round it to the nearest hundredth, and 27 hundredths. Okay, but again, if we go back to our problem, it asks us to round your answer to the nearest whole number. So our nearest whole number will be 127. Okay? So we're going to run out of space here. So I'm going to put up here. So C will be equal to 127. Not 25, 27. C equals 127. So if I put it back in, D is the same value as C. So if we go back to our original diagram, the value of our hypotenuse, or D, will be equal to 127 feet. Okay? And that's how we solve the Pythagorean theorem using the basis and the hypotenuse. Okay? So great. And I know when you solve this type of problem, because you may see this type of problem on your MSA test, when you see it, don't forget, you must square the basis. Okay? A squared plus B squared equals the C squared. Okay, let's move along to our next problem. Again, we have another composite figure. Okay, it represents Marty's yard. It says, what is the area in square yards of Marty's yard? Okay, we see it's not a clear square rectangle. It consists of, again, different shapes. So let's look at it. And remember, the figure is not drawn to scale. So if we look at what we see in Marty's yard, I can see there's a triangle right here. There's another larger triangle here. And then we have a rectangle in the center. Okay, so it says, what is the area in square yards of Marty's yard? Okay. Again, you're going to solve it just like you did the other problem. Remember what we did? We actually divided it up into different shapes, and then we came back at the end and added them all together. So this is what we're going to do. We're going to look at Marty's yard, and we're going to pick the shapes, break them apart, and then put them back together. So let's look at Marty's yard. Okay, so first let's look at the larger triangle at the bottom. And again, the area of a triangle is equal to 1/2 of your base times your height. So the area of this would be 1/2 base times height, so it can be 1/2 times 6 times 8. Okay, if we multiply it out, we get 1/2 of 6 is 3. Half of 6 is 3. So we get 3 times 8, and we get area is equal to 24. And again, it's square units. It's going to be square units. So that's area of a triangle. Let's call this the bottom triangle. This is the bottom. Okay, now let's go to the triangle, the smaller triangle. We have another small triangle. Okay, but this triangle, notice there are no numbers for this small triangle. So therefore, we must figure out from the numbers given, what's the value of the base and the height for this small triangle. If I look on top, the length of this top line is 14 yards. Okay, so the length of this bottom segment, which is the hypotenuse of the larger triangle, is 10. So if I know the entire line segment should equal to the entire line segment on top, because it's a rectangle, if the top is 14, the bottom should also, the entire line should be 14. So if I do 14 minus 10, I get 4. So down here will be 4 yards. Okay, now let's look on our side. Okay, this length of this side, the right-hand line segment, is 8 yards. Over here, from the top to this distance is 5 yards. If I subtract 8 minus 5, 3 should go right here. So this little line segment from here to here will be actually 3 yards. Okay, so now I can find the area of the smaller triangle. So again, we're going to use the same area formula, but we're going to call this one the small triangle, the small bottom, let's call it small, at the small bottom triangle. Okay, or just small, that's fine. Okay, so we'll have area equals 1/2 base times height. Area will be equal to 1/2, which is the same thing as 0.5. Okay, so I'll say 0.5 this time, or 5/10, times 4 times 3. Okay, we know that half of 4 is equal to 2, so we can say area is equal to 2 times 3. So the area would be 2 times 3, which is 6 square units. Okay, so that's the area of the smaller triangle. So we have the area of the larger triangle, the smaller triangle. Now we need the area of the rectangle. Okay, the area of the rectangle. So the area of the rectangle will actually be the measure of the area of the length times the width. Again, we said the length and width were 14 and 8. So area of rectangle would be the length times the width. Okay, so we substitute in, we get 14 times 8. And we know when we multiply it out, 14 times 8 will give us 112. And again, it's going to be square units. Okay, so now we have all the areas of the shapes that comprise our composite figure. Now, if you notice, this smaller triangle, it's kind of like an imaginary portion. Marty's yard, although it's the bolded aspects, this is an imaginary triangle so that we can actually find the area of the rectangle. So let's just find it. Let's just add all the areas we got for the smaller triangle, larger triangle, and the rectangle. Okay, so we're going to add, let's say total area is equal to the area of the bottom 24 plus the area of the rectangle plus the area of the small triangle. Okay, so we have 24 plus 112 plus 6, and we get 142 square units. Now remember, that's the area of the entire figure, including this small triangle. Now again, the bolded portion of Marty's yard is actually his yard. This was used so that we can find the area of the rectangle. So if we subtract that out, if we take 142 and subtract out the area of the small triangle, we will actually get area equals 136 square units. So that is our total area, excluding or without the area of the smaller triangle. So it's a trick question, but again, just make sure you take your time, read your directions carefully, and be sure you go back to check your answer to ensure you actually answer or solve the problem according to what you were asked to do. So again, we found the area of the larger triangle at the bottom. We needed this smaller triangle just to solve the area of the rectangle. Well, actually, you could have, if you were looking at your length and width, you may have figured out without finding the area of the smaller triangle. But this portion of Marty's yard, it just says find the area. So it could be included and it couldn't be included. So we can find the area of this figure with Marty, with this space included and without. So when we found the area of the larger triangle, the rectangle, and the smaller triangle, we had the numbers 24 for area for the bottom triangle. So we're going to add 24 plus the area of the entire rectangle was 112 plus, if we're talking about the entire figure, plus the area of the smaller triangle was 6. So if we add them all together, we would get 142 square units as our total area for the entire figure. Okay, now if we were just finding the area of this portion of Marty's yard, we would not include the smaller triangle. So therefore, the total area would be 142. However, if we're just finding the area of the outline portion of Marty's yard, that area, so I'm going to say outline area of Marty's yard, that area will actually be 136 square units. Okay, so just be careful. Make sure you read your question carefully on your assessment and make sure you understand what the question is asking you to do, because sometimes it can be a little tricky, and they'll put some answers on there that you may think is correct, but if you didn't go back and check it, you will know it's not correct. Okay, and we're going to move on to our final problem involving surface area. Okay, a prism, surface area of a prism. If we look at our shape, we have a prism. And then we also have, this is also a prism. Okay, so we have the prism on the paper, and I actually showing you this is an actual prism as well. But it says, what is the total surface area in square inches of the rectangular box? So rectangular prism is the same thing as a rectangular box. Now, what we need to find, if we don't have the formula for finding the total surface area of a rectangular box, we can use the formula, or we can just look at our figure and say, hey, this figure is comprised of rectangles. So if all the faces are actually rectangles, we can find the area of each face. So if we look at our prism, okay, if I were to cover it up, let's say this is my wrapping paper. I'm wrapping this box up. Okay, wrapping it up, going to ship it off. Let's see, this is my wrapping paper. This is my wrapping paper. I'm wrapping it up, shipping it off, shipping my box off to my, okay, so this is my rectangular prism. It's all wrapped up now. So the problem asks us to find a total surface area. So the total surface area is nothing more than, I wrap this up. If I were to take the wrapping paper off, what's the total area of this wrapping paper or this prism all wrapped up? So let's do that. Let's unfold the prism. Let's take off the wrapping paper. We're going to take it off. And if you see here, hopefully you can, we have a net. Okay, our net consists of 1, 2, 3, 4, 5, 6 faces. And the shape of each face is a rectangle. So in order to solve for the total area of the rectangular prism, we can just find the area of each face. And each face, again, is a rectangle. So the area of a rectangle is length times width. So if we look at our diagram or our net, we have 6 faces. So the area of each of the faces becomes our task. So let's do that. Let's find the area of each face of our rectangular prism. So if I move my net, I know I have 6 faces just from taking that net apart. So let's start with our first face. Let's look to the left and to the right. Okay, your left, my right. Okay, so if we notice, the length and the width are 6 and 8. So we have the opposite sides of the rectangular prism are congruent or equal. So if one side, length and width is 6 and 8, the other side, the length and width are 6 and 8 as well. So let's do that. Let's find first the left side, or the left face. Let's say the left face. Okay. And the right face. If we go back to our diagram again, the length times the width was 6 times 8. So if we multiply area equals length times width, we multiply 6 times 8, we get area equals 48. Okay. So same thing over here for our right side. Remember, because the left and the right side are congruent or equal to each other. So we get length times width. Area equals 6 times 8. So the area will be equal to 48. And again, it's square units. So we have two of our faces. We have the left and the right. Okay, now let's take the top and the bottom. So we look at the top and the bottom. We have two additional faces. So if we look at our diagram, we have the bottom, the length and the width are 18 times 8. So it's going to be the same as on the top, because again, in order for this to, the opposite faces, top and the bottom are congruent to each other. Okay, so we're going to multiply the 8 times 18. So we're going to take the top face and the bottom face. I'm giving them the names just so you'll understand exactly what I'm doing. So again, the area is equal to length times width. It's all length times width because each face is the shape of a rectangle. And the area formula for a rectangle, again, is length times width. So we have area equals 8 times 18. Same thing on the bottom because the two faces are congruent. 8 times 18. So if we multiply 8 times 18, we get 144. So the area on the top and the area on the bottom is equal to 144 square units. That's the area of the top and the bottom, each face. Okay, so remember we said we had 1, 2, 3, 4, 5, 6 faces. We had 6 faces total. So we have 4 of them. So now we're going to do the other 2. Okay? Okay, so now we're going to do the other 2. The other 2, we have the top and bottom. We have the left and the right. Now we need the 2 sides, the front and the back. Okay? So let's take the front face and the back face. Find the area of those. So if we go back to our problem, okay, this is our front face and this is the back face. Okay, so we notice the bottom is 18 inches and the side will be 6 inches. So the top, or the front, I should say, the front face would be area is equal to length times width. So we will multiply, again, the 18 times the 6 because we get our 6 right here. And these two line segments or edges are congruent. So 18 times 6 will compose the area of the front face. 18 times 6. 18 times 6 will give us 108 square units. And again, it's going to be the same for the back face of the rectangular prism. So again, let's multiply the back face area equals length times width. Area equals 18 times 6. So again, the area of the back face is 108 square units. Now, if we go back to our question, it says, what is the total surface area in square inches of the rectangular box? So if we go back, circle the area for the left, right, top, bottom, the front, and the back. If we add all these numbers up, that's going to give us our total area for our rectangular prism. So we can do it like this. We can just simplify. We can say 48 times 2 is equal to 96. And again, I got my 48 from the left face and the right face. The top and bottom faces would be 144 times 2. Got to make sure I put that T on right. Sorry about that, but I know you guys got it. Okay, 144 times 2, and I get 288. Then for the front and back face, we're going to multiply 108 times 2 because it represents the two faces. 108 times 2, and we get 216. Okay, so now we can add 96 plus 288 plus 216. And we do that quickly. We get our total surface area of 600. So total surface area is equal to 600 inches squared. Okay? Not too bad. Just remember to, if you're confused, look at your figure and divide it up into separate all the faces, find the area of each face, and then at the end you're going to add them up. Okay? Hope you guys have enjoyed the MSA prep lesson for today. I wish you many, many success on your MSA exam. Remember, check your answers, read the question carefully, and take your time. Have a great day.